The universe has many mysteries. One mystery that might make you curious is what the temperature is in space, how astronomers measure it. Trying to deduce the temperature of space is an interesting question. Unfortunately, there is no simple and straightforward answer. Temperature is a measurement of the kinetic energy of material particles. Astronomers often refer to the temperature of a region of space to indicate the kinetic energy of matter in that region. In general, there is not enough matter in space to transfer heat or coldness to other objects. So if you place an object in space, the temperature it reaches depends on how much radiation it receives and how good it is at absorbing and emitting that radiation. However, temperature is only a measure of the heat balance between an object and its environment, and not the temperature of space. So, what temperature can we measure in space? Reporting from BBC Sky at Night, space itself does not consist of matter and therefore has no temperature. There are many variations in temperature throughout the universe. The coldest temperature that occurs naturally in the universe was discovered in the Boomerang Nebula in 1995. This cloud of gas and dust, in the constellation Centaurus, was released by a star nearing the end of its life. Its temperature, as a result of the slow expansion of gas clouds, is only -272 degrees Celsius. The hottest temperatures in space, most likely produced in the catalytic interactions that create gamma-ray bursts, may be as high as trillions of degrees. Between these two extremes, there is a very large temperature range and the temperature of the object is constantly changing. How cold can something get? Physicists have determined that there is a lower limit on the temperature scale called absolute zero. This temperature occurs at -273.15 degrees Celsius or 0 Kelvin. No matter how cold something is, it can never reach absolute zero even if it can get close. Strictly speaking, the coldest place in the universe was in a laboratory in Finland in 2000, when the temperature was only 1/100 trillionth above absolute zero. What about the overall or average temperature of the universe? Astronomers often consider the temperature of the microcosmic wave background to be the temperature of space. It is 2,735 K or -270,415 degrees Celsius. Microcosmic wave background is the oldest image of light in the universe. This object was imprinted in the sky when the universe was only 380,000 years old and first became transparent to light. The Big Bang Theory predicts that as the universe expands, this temperature should fall, just as the expanding gas cools. This is exactly what astronomers found. By deducing the temperature of the microcosmic wave background at various distances in the universe. When microcosmic wave background radiation is emitted, the temperature may be around 3000 Kelvin.